Hey everyone! Today we're going to tackle one of the topics that really trips people up in C programming exams, loops. If you've ever stared at a block of loop code and felt your brain start to ache, you are in exactly the right place. Let's dive in and crack this thing wide open.
So take a look at this. At first glance, it looks pretty intimidating, right? When something like this shows up on an exam, it's super easy to panic. But honestly, don't worry. By the time we're done here, you'll have a clear roadmap to solve problems just like this one, and fast.
Yeah, these complex loops, especially when they're nested inside each other, can totally feel like a maze. It's like every line of code could send you down a different path, and before you know it, you feel completely and utterly lost.
But here's the good news. Every single maze has an exit, and for us, we have the keys to find it. Those keys are the loop structures themselves. So let's start looking at these keys one by one and figure out how to navigate this maze together.
Okay, our first key is one of the most fundamental tools in pretty much all of programming, the for loop. This is your go-to, your absolute best friend for any situation where you know exactly how many times you need to repeat something right from the get-go.
The whole idea behind the for loop is super straightforward. You set a starting point for your counter, you define the finish line, and you say exactly how to take each step. Start, finish, step size, it's all laid out right there. It's kind of like a runner who knows they need to run exactly 5 miles. No more, no less.
All right, let's put this key to the test. Here's a classic exam-style question. What do you think the output of this code is going to be? Go ahead, pause for a second and work it out. You got it?
And the answer is 0, 1, 2, 3, 4. If you got that, awesome. If not, no worries at all. We're about to walk through the logic step by step.
So what's actually happening under the hood here? Well, first, the loop initializes our counter I to 0. Then it immediately asks the question, is I less than 5? Well, 0 is less than 5, so that's a yes. It runs the code inside and prints 0. After that, it increments I. Now I is 1. The cycle repeats. Is 1 less than 5? Yep, print 1. This goes on until I becomes 5. That's the crucial moment. The loop asks, is 5 less than 5? And the answer is no. The condition is false and the loop stops right there. That's why we see 4, but we never see the 5.
Let's grab our second key now, the while loop. If the for loop is that runner who knows the exact distance, the while loop is more like a guardian at a gate. It just stands there and keeps going as long as a specific condition stays true.
You see, the real power of a while loop is in that uncertainty. We don't need to know if it'll run 10 times or 1,000 times. All it cares about is whether its condition is true. As long as it is, the loop will run. And yeah, it could even run forever. We should also give a quick shout out to its cousin, the do while loop. It works the same way, but with one big difference. It guarantees the code runs at least once before it even checks the condition. It's the act first, ask for permission later kind of loop.
And here we go, one of the most common trick questions you'll see. What's the output for the code on your screen? Take a close look. Does it feel like something's missing?
The answer is, it's an infinite loop. If you fell into that trap, don't feel bad. This is probably the #1 mistake people make with while loops.
So why does this happen? It's because nothing inside the loop is changing the condition that keeps it running. The value of I starts at 0 and just stays there. So the condition, I less than 5, is always true, and our program just gets stuck running forever. So here's the critical takeaway. With a while loop, you absolutely must have something inside the loop that will eventually, somehow, make that condition false.
You know, loops don't always have to run from start to finish. Sometimes you need a secret passage, an emergency exit, or just a way to skip ahead. And that's exactly where break and continue come into play. Okay, let's check this out. We want to see what the continue statement actually does. The loop seems simple enough. It looks like it's going to print numbers from 1 to 5, but there's that little if statement hiding in there. What do you think is going to happen? And the result is 1, 2, 4, 5. See that? The number 3 is just gone. It got skipped. And that is precisely what continue does. It immediately stops the current round, or iteration, and jumps straight to the next one. It's like the loop saying, you know what, I'm going to pass on this one. Let's get to the next round. This table really nails the difference. Think of break as the emergency brake. You pull it and the whole loop screeches to a halt. Done. Continue, on the other hand, is like skipping a song on a playlist. You just skip the current one and move right on to the next. So, break says, I'm out of here.
while continue says, let's just skip this part and keep going.
But just solving exam questions isn't the whole story. A truly good programmer writes code that's not just correct, but also clean, efficient, and easy for other people to read. So let's quickly cover a few golden rules for loops.
Ever seen this before? It's called Big O notation, and this one, O of n squared, is all about time complexity. What it means is, when you nest loops inside of other loops, your program's performance can slow down, like a lot. For example, if one loop takes 10 steps, nesting another one inside it could take 100 steps. A third one could take 1,000. For big jobs, this can slow your program to a crawl.
So, here are a few quick tips. First, be really careful with nested loops. If you can avoid them, do. Second, always double-check your conditions to avoid those infinite loop traps. Third, try to use break and continue only when you really need them, because they can sometimes make the code's logic harder to follow. And finally, please, instead of just I, J, and K, give your counters names that make sense, like row index or customer count. Trust me, you'll thank yourself later.
Okay, now it's your turn. You've got all these keys in your hand. Let's think about a trickier problem. How would you write a program to find every single prime number between 1 and 100? Would you need an outer loop? What about an inner one? Is there a point where maybe using break could make your code run way faster? This is the perfect challenge to put everything we've talked about together.
So remember, at the start, loops might look like an impossible maze. But now, you hold the keys. You can count your steps with 4, you can wait for the right condition with while, and you can even bend the rules with break and continue. The code to the maze is yours. Good luck.